Hello everyone, welcome to the 9.3 Notes Day 2. We're going to be talking about limits from a graph, and I have a different situation here, more examples, so hopefully it's good to hear this from a different perspective. So whenever you see the word limit, what that really means is, or what you should ask yourself is, what y value am I approaching? So a limit doesn't mean exactly what y value, it means what y value am I getting very close to, but not necessarily touching. So it all kind of depends on where you're looking from. If you ever see something like this, the limit as x goes to 4, then you see a little minus, this really means you're talking about looking from the left. If you ever see the limit as x is going to 4 with a little plus, that means you're really looking from the right side, so you're looking from this way. From the left, you're looking from this way. And if you ever see the limit as x goes to 4 without a symbol, that means you're going to be looking at both directions at the same time. And so let's take a look at some examples that are given here to kind of clarify this, but also just talk about notation. Part A says, based on this graph, what is f of negative 4? If you ever see this notation, this is asking you what exact y value you're dealing with. So if we go over to x is negative 4, which would be right here, and we look up at the graph, we have two dots. We have an open dot here at 1 and a closed dot here at 2. If you're talking about what the exact y value is, the answer has to be 2, because this is a hole, and so the y value doesn't exactly exist here, but it does exist here. Okay, so the answer for part A is 2. Now, all of these limit problems are written in a specific order to help you understand. So here, the limit as x is approaching negative 4, and then this little symbol right here means you're going from the left. You're looking from the left side because that little negative there. So if we look our attention here at negative 4, here's the graph. We're going up first, we're going back down, and we are approaching at x equals negative 4, we are approaching the y value of positive 1. And so notice there is a hole. So as I'm not saying that the y value is exactly 1, I'm saying that you are approaching or getting close to the value of 1. So your limit from the left side is positive 1. If we look at negative 4, but this time we have a little plus. So we're looking from the right side. So the graph starts over here, jumps, makes more of a parabola, comes up here, and then it's coming towards negative 4. And again, the graph looks like it's approaching this position from this direction, and it's also approaching 1. Part D says as x is approaching negative 4. Now, when it says this, it means you need to consider both of these situations at the same time. If I approach this limit from the left, I was approaching the y value of 1. If I was approaching from the right, I also approached 1, which means the limit does exist, and the answer for here would be 1 as well, because from both directions, the limit is the same. So I'm going to write a note. Both directions, the limit was the same. And because the limit's the same, the answer is also 1. You'll see some situations later that is not always the case. Let's take a look at part E, f of negative 2. So this really means what is the exact y value at x equals negative 2. So if I go over to negative 2 and look up at the graph, I have a hole at 5 and a closed dot at 4. It exists here. So the actual y value answer is 4. If we consider a limit, though, a limit means what y value are we approaching, not necessarily touching. So we're going to look at negative 2. We're going to look up and down here. As the graph is coming from the left, so this little negative here means, again, looking from the left side. We're coming up, going back down, going up, and as the graph is approaching x equals negative 2, we are approaching the y value of positive 5. It does not matter that there is a hole here because you are just getting close to 5. So the limit from the left is 5. As we approach negative 2 from the right, hence the little plus sign, the graph jumps a lot, makes a little parabola, and as we're coming towards negative 2 this time, the y value that we're approaching is not 5, it's now 4, because coming from this direction, the graph only exists up to here. So the y value from the right is 4. So part H is interesting, because if you're asking for the limit at exactly negative 2, the limit from the left and the right are not the same. From the left was 5 and the left was 4. So that means that the limit at exactly that point does not exist because the left and right were not the same. So let's take a look now at f of 0. If we look up at the graph, if we look at the x value of 0, and we look up and down, we have a hole here at 2 and a hole here at 4. So does a y value actually exist at x equals 0? It does not, because we have 2 holes and not filled in points. So my example, or my answer here, would be does not exist. But if we take a look at the limit, so if we approach it from the left and approach it from the right, part J says x is approaching 0 from the left side. So let's take a look there. As I'm looking at x equals 0, the graph from the left goes up and down, get this little parabola shape, and now we're approaching the x value of 0. And from the left, it looks like we're approaching the y value of 4. So the limit from the left, the answer is 4. Not because it's exactly 4, but we're approaching it. Now, part K says, what if we look from the right? So if I look back at my graph, the graph goes up, comes back down, then we're approaching 0, and this time we are approaching the y value of 2 from the right. So my limit is 2, which means my answer for L, the limit at 0 exactly, is the limit the same from the left side and the right side? If it is, like the first row, the answer is the same. If the limits are not the same, like the second row, the answer does not exist. And here, the limits do not exist because it is not the same from the left and the right. And yes, I'm sure a lot of you right now are thinking about Mean Girls. I mean, I would too, because you're thinking, oh, the limit does not exist. I mean, it's a top-notch movie. I don't blame you for thinking about it. So if we take a look, anyway, at part M, let's take a look at f of 2. So we're looking at the x value of 2. So if we look up and down here, is there anything exists, any y values that exist up and down here? Yes, right there, the y value is 0. So at x equals 2, the y value is 0. The limit as x approaches 2 from the left side. So if we take a look at this line, and we're looking from the left, the graph goes up, parabola, then going towards 2, the y value is 0 from the left. So we're approaching 0 from the left side. From the right side, the graph starts here, jumps, comes back up, and then it looks like as I'm approaching the x value of 2, we are getting close to the y value of -2. So the limit from the right is -2, which means my answer at 2 exactly, you have to consider both directions. Both directions are not the same, so my answer is D and E again. Last piece of this, if we look at f of 4, we're asking what y value exists at 4. Now this one's interesting. We have a vertical asymptote here at 4. So are there any values that exist at 4? No, because we have a vertical line we can't cross. So this example would be D and E, does not exist. If we look at the limit from the left side, and this is interesting. So this time we're looking again from the left. If we look at what the graph is doing from this direction, we're starting here, going down, going up, parabola, going down, jumping. Then the graph, as we're approaching 4, shoots down this direction. So it looks like the graph, if we're getting really, really close to this line, is going to keep going down and down and down and down and down towards -infinity. So my limit is -infinity, because the graph, the y value technically is going to be, the y value really doesn't exist, but the graph's end behavior is going towards -infinity. This piece, as we're looking at the graph going from the right side, because we have a little 4 plus, the graph starts here and then goes up, 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 up. There should be a little arrow there. So as the graph is approaching this line of 4, this x value of 4, the graph is going all the way up to +infinity. So the question is, are these the same? Is -infinity the same as +infinity? It's not. So the limit at this x value of 4 does not exist. And it doesn't exist because the left and the right are not the same. The reason some people might get confused. They might say, oh, there's a vertical asymptote, so there can't be a limit. That's not true, because a limit, remember, means that you are approaching something. So you're approaching this from the right, going to positive infinity, and approaching this from the left, it's negative infinity. Okay? So one more thing that I'd like to bring up that was not a problem that I gave you originally, but might be good to chat about. What if I asked you two things? What if I asked you, what is f of 10? Even though f of 10 is not on this graph, this horizontal line is going to go forever and ever and ever in this direction. And this horizontal line is intended to be at x equals 1. So if you think about it, if you go to 7, 8, 9, 10, isn't the y value going to be 1 all the way forever because you have an arrow? So your f of 10 is just going to be a y value of 1. Sometimes you see that situation come up with limits, so I thought I'd throw that out there. Another something that you see that could be helpful is, what if I asked you what the limit is as x is going to positive infinity? So what this means is, as x goes to positive infinity, that really means as the graph is going to the right, what is the y value doing? So the graph, if you're going this direction, after this line is going to go downwards, and then it's going to continue forever in this direction. Because this line flattens out, think about, as x goes further and further and further and further and further towards infinity, is this line ever going to change from y equals 1? No, it's not. So similar to how I asked you f of 10, where the f of 10 value, the y value is going to be 1, this is kind of like a horizontal line you can't cross. The limit as x goes to infinity is also going to be 1, because this graph is slowly and slowly and slowly and slowly and slowly approaching 1. So guys, I hope this was helpful to hear this again a second time from a different teacher. Please use it to help with your practice problems today. You can pause, rewatch it if you need to. Let me know if I can help you in any way with the live chats. Thank you.